Welcome to the Crazy Wisdom Podcast. I've got Larry Swanson here, and he is a knowledge architect, community builder, and host of the Knowledge Graph Insights podcast. Welcome to the show.
Hey, great to be here, Stuart. I'm really excited to talk with you.
We're going to have a great conversation about ontologies. And knowledge graphs and all these other, what is the relationship between a knowledge graph and an ontology? And maybe for our listeners, why are they important?
Yeah, I think, well, they're important right now in the context of AI. The generative AI is kind of showing what it's capable of and really good at and where it needs some help. And symbolic AI, which the topic of knowledge graphs and ontologies fits into, is like here and ready to help. But the classic definition of a knowledge graph would be like a combination. Well, and not everybody agrees on this. This is my opinion. I'll just phrase it that way for any of my friends in the field who are listening, because there's a lot of people who are more precise and experienced than I am. But as I understand it, a knowledge graph is it's built with an ontology that describes a domain that you're curious about, that you want to be able to answer questions about or discover things about or do things with, like agentic AI. I think knowledge graphs are going to be very important for that. So you have an ontological understanding of a domain, like what are the things in there? How do they relate to one another? And then you have instances of all those things that you're concerned with. So it's both an ontological description of the terrain and then mapped to instances of stuff in that terrain. I hope that's not too abstract.
No, it isn't. It's hard for me to tell these days, just because I spend so much of my time in abstractions. As all of us have to do, right? Because we live in this strange world where everything's on the internet, which is abstract. So knowledge. So I love that ontologies have become really important for technology. They've always been important for technology, as you talked about. Neurosymbolic AI goes back really far, and they had a lot of issues with it, and it didn't really work in the way they expected. But then Yahoo kind of like created these informal ontologies that powered the early search versions, and then Amazon, uses ontologies for their entire product catalog. And I love that it's a deeply philosophical thing. Like there's like ontology. It's the nature of being, right? That's what an ontology is.
Yeah.
Is the nature of being.
Well,
But then,
it's actually the nature of what you know, which
What
is
you know,
really. Yeah, I live in Heidelberg, Germany now, and I'm surrounded by philosophers. And so I've never formally studied philosophy, but I'm kind of backfilling. And it's really interesting to see how much of this stuff I've learned in the ontology engineering and knowledge graph world, to go upstream to its philosophical roots. It's pretty
and what are they?
fascinating.
What are they? What are the?
Well, among them, the two main ones would be ontology, like, and epistemology, like, how you know what you know and what you know and accounting for what you know. So epistemology and ontology fit in that way, but also logic. One of the things you can do with a resource description based, the RDF formatted knowledge graphs, is you can do like logical reasoning over stuff that you know about. And so logic comes into it as well. And all of which I'm like I had one really shitty philosophy experience in college and just kind of like walked away, like disgusted with the whole discipline, not disgusted, but disappointed. And then now here later in life, I'm discovering there's really connected with a really good teacher doing some philosophy workshops here and stuff. So I'm just starting to get my head around. And I've always been like a logical thinker and pretty rigorous critical thinker and stuff. But now I've got all this philosophical, thousands of year old knowledge to stitch it all together. It's kind of cool.
Well, no, and it, there's a lot of different ways we can go. So it's back to that abstraction point, because we all live in these abstractions, but then we are in a strange time period where the institutions are having a lot of challenges. And I think philosophy becomes really important in these times where there's a lot of challenges, because essentially like we have to, 20 years ago, 30 years ago, the epistemology of civilization was set from the United States, like 1990s, like global superpower finally won. And all of that is sort of like collapsing a bit. And so in that collapsing, that's when philosophy becomes important, right? Because we have to we have to create a new one, right? Because the structures are all collapsing. We have to create new structures. And that's where philosophy comes in. And it also where knowledge management and ontology comes in, right?
Absolutely. I had not framed it the way you're talking about it, but I 100% agree that that's a really useful approach to our current status in the world.
Yeah. But it's super abstract. But then it does allow us to do things, right? Because an ontology and a knowledge graph allow us to do things inside of business, right?
Exactly. Yeah, I think that's the real the strength of it. Like that, because it's like
Oh,
what do you know and how do you know it? And what can you do with that knowledge? It's like it's a whole. It opens up. I mean, yeah, there's a lot to that, and this could get really philosophical really quickly. But I love that you see philosophy as an important like prerequisite to going forward here. And I think that's something that like the knowledge graph world and the semantic web. And that's the other thing I didn't say about knowledge graphs. They kind of come out of, or not come out of, but they're related to the notion of the semantic web. Or do you know
mm,
that term, or did you and
I
Jessica
have
talk about that?
I have
Yeah,
heard of that. I'm sure she talked about it. One of the things I love about
yeah.
the interviews with Jessica is that she throws a whole bunch, and I catch like 20% of it. And so semantic web. So semantic web is basically Tim Berners-Lee connecting different pieces of the internet together.
Yeah, basically, well, it was Tim Berners-Lee and two other guys, Jim Hendler and Oral Ossola, wrote this famous article in Scientific American 25 years ago, almost exactly. It was May of 2001. And in fact, it's not out yet. It'll probably be out by the time this podcast drops. I just interviewed one of his co-authors,
Very cool.
Jim Hendler, one of the authors of that paper last night for my podcast.
Wow.
And so the semantic web was this idea of it's then the story I got from Jim is fascinating. It's the kind of the history of AI culminating at this point 25 years ago in sort of the convergence of like the web is not just the collection of documents, which is what HTML and HTTP, let you do is connect documents across the web. There's all kinds of brilliant things about that, which Tim Berners-Lee invented, which is kind of handy. But then, and Oral Ossola famously tells the story of years later, like I don't know, I guess the early 2000s, late 90s, early 2000s, something like that. Tim Berners-Lee coming into his office and go, "Hey, we got the documents connected. What about all the
Mm,
data? Could we just turn the internet into a database?" So I'm oversimplifying that conversation, but that's basically where RDF, that technical standard I described earlier, that is the thing on which you build knowledge graphs and ontologies. So RDF kind of came out of some research that Jim had done at DARPA, that culminated in like a simple ontology they developed. Like the acronym, I forget exactly what it stands for. The acronym was SHOE, SHOE, simple HTML ontology something. And so out of that, and out of like Aura, kind of, I think came more out of like the semantic, maybe the logic world. I forget their exact backgrounds, but anyhow, it was this convergence of Jim Hendler, Aura Ossola, and Tim Berners-Lee, each of whom had a slightly different perspective, and they kind of came together and crafted this vision of like the
so
whole internet being, having data associated with it, which is really cool. And yeah, we could
so
talk. I could talk. Yeah.
Tim Berners-Lee created okay, so that's what the semantic web. So the semantic web is coming from these guys, and I didn't realize Tim Berners-Lee was involved with RDF, and
Yeah.
so they created this semantic web, and the semantic web was trying to create a database out of the entire internet, and that's where RDF
Yeah.
came from.
Exactly. Basically, and again, I'm like oversimplifying a lot of this, but the idea was that you could equally have data and more importantly, metadata. That's how it started. One of the origin stories I got from Jim last night was that it started with one of his grad students. I think he was at the University of Maryland at the time, trying to remember somebody they'd met at a conference. The guy's name was Cook. And in all the data, these guys have powerful databases. This is like, they're all high end,
Yeah.
supercomputing, database people, and they've got all the resources in the world at their disposal. They didn't have a way to disambiguate Cook, the the noun or the verb or whatever, from this guy named Cook. And so they were like, and they started brainstorming and going, well, like every university has a list of faculty. If we could just attach to that HTML page information about like, this is the guy's name, this is his discipline, this is the conferences he went to, or something like that. So that's one of the origins, was that solving that problem was like how to, and this gets into the semantic part of it. That's the meaning part of it. Like how do you
Mhm.
put meaning on the web? If you just have like connections between documents, that's obviously super handy. But if you understand what those documents means, even better.
Okay, great territory. There's a bunch of follow up questions. I want to ask you because I go back and forth between the knowledge management community and the knowledge graph community and my engineer friends who are at the very cutting edge for AI. and they're like, none of this stuff is important. I've done ontologies before. None of it's important. AI is going to take care of all that. And then they convince me, and then I go back to someone like you or someone like Jessica, and then I get convinced back in the other direction. And so one of my favorite engineers, he says that RDF is like something that academics come up with that is like good for consulting businesses and stuff like that, but doesn't really do anything. Do you agree or do you disagree, or do you have any nuance to that?
Strongly disagree. But also the first thing I want to say is we're all right. Like that there's those three fields those three fields you just mentioned. It's kind of related. One of the concepts in ontology modeling is like scoping your domain and then figuring out how you look at it. Like one of my friends who's working on a book about domain modeling talks about you have a domesticated animal. The pet owner looks at it, there's Fluffy, and Fluffy needs to eat at XYZ time. The veterinarian looks at that, critter as like a biological entity that needs care. The pet store owner looks at it as inventory, so the same entity there, so there's that's how it all starts, is with that. So anyhow, those three disciplines you mentioned, that I just offered that as an example of like, I think it's like that old story of the wise people encountering the elephant, the blind people, and they're going like, oh, it's clearly a big leather wall. No, it's a hose. No, it's a, it's like that. So the knowledge management people, brilliant people, and I know a lot of them, and they've traditionally done, and they're really good at a lot of the foundational work that's important to knowledge management, which is like getting tacit knowledge out of people's heads and documenting it. That's every enterprise's concern in the world right now, because all the boomers are aging out and retiring, and it's like, holy shit, what's happening to their knowledge? So the knowledge managers, and I'm again grossly oversimplifying each of these fields, but I have friends in all of them, so I can speak a little bit about it. So that's knowledge management, is like the really good practices around, getting stuff and getting it into corporate wikis and training programs and stuff like that. The machine learning engineers, there are tons of friends in that field, and I have probably the same conversations that you have going back and forth, like with Jessica, where like I often get like exasperated with them because they're like, and not to diss them, but like, you can't learn everything. You can't figure everything out with machine learning. That like, maybe you can, but even if you can, why would you? Once you've learned something, why don't you ensconce that knowledge? And those latter two, the machine learning, neural network based learning technologies, vis-a-vis symbolic AI, the knowledge representation and ontologies and knowledge graphs and all that stuff. They're just like what Tony Seal, one of my favorite, and here's another guy you should talk to. He's amazing, kind of like a really good evangelist for knowledge graph technology. In fact, he goes by the knowledge graph guy. That's his moniker. But he talks about the two, and a lot of people talk about the two main kinds of AI right now in this way, is like kind of like Kahneman's thinking fast and slow, the slow brain, right brain, the fast brain's slow brain. And so you can think of, this is again gross oversimplification, but it's a useful analogy, I think. Like LLMs is like the learning monsters. They can read the whole internet and summarize all your research that you missed because you're too busy doing your own research or whatever. LLMs are amazing at that, and learning and pattern recognition, natural language interfaces. I think that's why they've taken off, because it's kind of like super NLP, to the point of like, really plausible human conversational interfaces. So they've got that going on. Meanwhile, over here on the symbolic AI, we've got like actual knowledge and facts that can, counter the hallucinations that, they're prone to and that stuff. So anyhow, there's a natural complementary nature between them. And what's funny, that leads to the reemergence of the field of neurosymbolic AI. Because early on, it was the early conversations like 40, 50, 60 years ago, they called it then connectionists versus symbolic AI. And the connectionists were the people who were like trying to mimic the human brain, the neural network, the neural stuff. And the symbolic AI people have always come out of more and again, this gets back to the philosophical, that's all the people the logicians and knowledge representation people. That's a whole field. And what's fascinating about it is all this stuff predates the internet and the web and the semantic web. It's always been there, and people are just putting it together in different ways. And then bringing us back to the present day in those three cohorts you mentioned, the knowledge management people are just like, holy shit, my boss said I got to capture all this precious organizational knowledge and do something with it, and they're doing the best they can. The machine learning engineers are like, they've got all the budget right now, and their boss is saying, we got to do AI and we got to learn everything. Here's a bunch of data, go have fun. And then I don't want to, but then the knowledge people are always been off in the corner and kind of semi-justifiably described as like the pedantic. Yeah.
So the knowledge management people and is the knowledge management people and the knowledge graph symbolic AI people. That's the third one you were just talking about, right?
Yeah. Well, I would just, it's a pretty clear distinction between the two, because knowledge management is concerned, it's really like an organizational, like not like HR, but it's kind of more in that category of like, of that kind of like, it's an acknowledgement of the stewardship of that precious knowledge has to be done. And knowledge manager, and again, that's the field I know the least best of these, but I know plenty of people in that field. Whereas the knowledge engineers, the knowledge graph people, they're the ones who are like, cool, you got some facts, let me do some really precise, mathematically valid, and architecturally sound connections, between those facts. That's what the knowledge engineers are concerned with. Yeah, I think, and if you could magically mush all those three, that's what the next 10 years is going to be, I think, is those three disciplines and others coming together to figure this all out.
I love it. All right. So this gets directly into what I was talking about before the show, getting hired at this company. And as a director of knowledge management at a scaling startup, which had no knowledge management, and trying to understand that you definitely categorized that correctly. It was a steward of the knowledge. But I was missing these other pieces. Well, there were machine learning engineers, but there were no knowledge architects. I really like the knowledge architect type. And the funny thing about that role was this was for a company that had figured out how to do RLHF, reinforcement learning through human feedback, for the AIs to funnel to those machine learning engineers who you're talking about, who are just like, we need it all, give me as much data as possible. And now we're at the very end of that data journey where we've harvested all of the public internet semantic data from the internet to do this super NLP that you're doing. We're at the very limit, and these labs now need to create their own data, either through synthetic data, and I think they're probably going to do some of that neural architecture, but they don't even know about it. That's like a lot, like it's so the knowledge architecture is so hidden for some reason. It's just like you know about it because you've been interested in this field, but a lot of people are not aware of it, including business people, and it feels like it's going to get really important really quickly. But before going into that knowledge architecture role, the RLHF is interesting because what they were doing, it's reinforcement learning through human feedback. In 21 and 22, the OpenAI ran into a problem where they are trying to automate everything else. They're like those machine learning guys who, like Facebook, like just get the human out of the loop. The machine gods are coming. Like, we don't need the humans anymore. Like, let's just get them out of the loop. And they ran into this problem, which is that the LLMs, the early versions of the LLMs, sounded like crazy people. Like, would lie, would hallucinate, would threaten, would do all these just crazy things. And they realized the only way to solve that is hire a Mongolian horde of human people all around the world, a lot of whom were in Argentina, which is why I'm here, or how I ended up here, and just like train the thing to how to respond politely and everything like that. And so it brings up all these important aspects of knowledge, because those machine learning engineers, I love them, but also you can't, the human is really important in a lot of different ways. And I think what I'm getting this intuition for ontologies is that it's really important for AI, because AI does all these things. I have no ability to understand what it did, because it did like 1 million things behind the scenes, and then doesn't have any self-representation, doesn't have an idea of who it is behindhand, so can't accurately tell me what it did. And so I'm just like mucking about in this giant code base, and I'm like, what happened? And then it documented knowledge, but I can't go read all that documented knowledge because so much of it is not relevant to what I'm doing. And like an ontology seems like sitting down and thinking about the business might be really helpful for the machines. And that's what I've understood from you guys, is that you primarily do this for the machines to traverse. But now I'm wondering whether building ontologies is actually really helpful for the humans inside the business to actually understand what the AI is doing.
definitely a two-way street. And in fact, and this is one of the ways, back to that neurosymbolic loop, the benefits between the
Right.
complementary natures of the two technologies. One of the things that's traditionally been really hard about building knowledge graphs is that to extract the entities and understand what's going on, get instances of all this stuff, all the examples you need, and the taxonomic terms that describe the things in domain, all that stuff has been notoriously difficult. LLMs are great at that. So I was really excited. I remember the Knowledge Graph conference at 2023. I went there expecting everybody to be excited about, about Knowledge Graph's ability to contribute back in, but they were all excited about the ability of LLMs to help them build their knowledge graphs. So there's that's the first half of the virtuous cycle. And now we're getting to the point where the fact that you're working with next token prediction and vectorized, just applied linear algebra to like predict, and it results in really plausible sounding language, which is kind of scary because it's never based in fact, it's based in math, and so that's where, but anyhow, and also to what you were just saying, the other thing one of the things that knowledge graphs bring is that, factual knowledge, and it's especially to the human stuff you were talking about. The thing about ontologies is that they are both machine and human readable. And, because they're symbolic, they're letters and numbers and things that human beings can understand. LLMs, the engineers who built those systems cannot explain what they're doing fundamentally. You have no transparency, no, so I think, we're obviously in an era where trust is like broken all over the place, and to restore and reinforce and demonstrate trustworthy behavior, you're going to need like facts and reality somewhere in the system. And that in terms of that part of the human equation, because ontologies capture human knowledge and ensconce it in a way the machines can work with it, we've got a hope of getting humanity back in the system.
Yeah, interesting. And it's so weird coming from San Francisco because that's not their plan at all.
No,
like it's
exactly.
yeah,
Yeah.
which is its own can of worms philosophically to talk about. We don't have to go into that. So but that's also the other thing. Why are knowledge architects so underappreciated, and how is that changing due to LLMs? Is there recognition that like what we're talking about is real among people outside of the community?
Yeah, I think, that's a really interesting one because within the community, well, a couple things about that. One, it is hard. And I understand, not that
Yeah,
not that machine learning engineers are not
yeah,
smart and they're lazy. I mean, they're all obviously brilliant, equally educated.
philosophically hard. It's
Just
cognitively hard,
yeah.
right? It's
Yeah,
cognitively
cognitively
hard.
difficult. Yeah, it's a shift, and it is more human oriented. Like you have to talk to
Yeah.
people to build a proper ontology. And engineers, I know, I've been working with them for 30 years. They hate talking to people. That's why I've always done what I do, because I love talking to people and I can communicate what they want in language that engineers understand. That's it's, but anyhow, fundamentally that's just how we're going to keep people in this, is with this technology. But the thing, to kind of what you just asked about, you're right, it's really difficult. And most of the people, like the advanced practitioners, have PhDs, in computer
Mm,
science or logic or philosophy or something like that. Um, and they are, in terms of like, from like a machine learning perspective, we're definitely underappreciated and unappreciated in many senses. But in enterprises that need facts, like, doing pharmaceutical research or financial fraud detection or that kind of thing, they love their knowledge engineers and they appreciate. And all my ontology engineer and knowledge graph construction building friends, they're all super busy right now. So the appreciation is there in the enterprise. The other thing, I did an interview on my podcast almost a year ago, I think, with a guy who's at AWS at the time on the Neptune team, but Charlie Ivey, a really brilliant guy. And he talks, one of the things, back to the semantic web, this whole technology stack and all the idea about semantically connecting the knowledge on the internet. A lot of people say, it's just a failure. It's just the whole idea from 25 years ago. And it's like, no, Charlie is like, first of all, more than half the web pages on the internet have semantic markup built into them. RDF formatted markup. Have you ever heard of schema.org? If you've ever done any SEO, and the schema.org markup, that's RDF. That's an application of this technology we're talking about. The other thing is that literally every big enterprise, Netflix, LinkedIn, Amazon, Meta, all of them have knowledge graph technology in the background. Like at LinkedIn, it's the economic graph. At Amazon, it's the product graph. At Netflix, it's like all kinds of crazy cool graph stuff. So Charlie, so the culmination, Charlie says, well, it's the most astoundingly successful failure in the history of technology.
Uh, Man, okay, that's good. Um, because so I guess the real question is, why don't startups even think about it? And I think I already know this answer, because the startups don't think
Mhm.
about it because it feels like too abstract. It's too not related to the bottom line of like, we're a startup that needs to survive. It only comes into the enterprise once Netflix gets this giant database, or once Amazon came with it, right? Because they had to do that in 1997 because there was no search. Like, how do you build a search for all their products without an ontology? And then, Netflix has this giant database, and so it feels like startups just kind of like are not like they just don't think about it. and
Mhm.
and that's why it's never the sexy thing inside of a startup. It's not like a new database or a new like a Stripe type of thing. Like, it's just like doesn't exist in that realm. um, Another question that was coming to me as this we were talking was that it feels like ontologies, as we were talking about, are really good for the human to build an ontology so that they can understand themselves within this context of this business or this other thing. That feels like really practical, even though it's abstract. But when I go and do my research, it feels like no executives or founders think about their entire business in the realm of context. It's only like Netflix needs this ontology to solve this specific thing. Amazon the same way. Is that true? Do you know of any company that really?
Yeah, a couple things to what you just said. One, I think the reason startups are less inclined, they just don't need it yet. It's like it's when you get to the point where things have got so big and complicated that you need to like step up a level and
Mm, mm.
and describe things in a way. But when you have a lot of it's you've obviously got a business focus, so it's not a crazy unmanageable project, but it's a big project to do it. So right now,
Yeah.
all those examples I gave are big enterprises or big scale up, giant scales ups. Like, I don't even
Yeah.
Amazon and the Fang companies, kind of thing. Um, but so there's that. Yeah, I think that's a really germane issue, but is that scale thing. But kind of in between that, like the schema.org, 90% of that is like small businesses trying to get
Interesting.
discovered online. So there's a weird distribution of the knowledge about this stuff.
Yeah.
Like the schema.org, it's not really an ontology, it's sort of a vocabulary. Some people would argue that it is an ontology, but an attempt to like help you organize stuff about on the web.
Mm,
Um, um, that's an application, but that's one where it's not like that. This is part of the reason why the semantic web, it hasn't taken off the way they originally hoped, because how do you, like when I was talking earlier about domain modeling, the thing that really makes an ontology sizzle and perform
mm.
is the fact that you've really focused on a domain. You're really, really clear about what you need it to do. There's all this notion of like competency questions and use case analysis, like really figuring out what you need that ontology to do. If you're doing that for the whole web, that's a little broad. So the
Got it.
closest anybody has come is like there's been attempts at upper level ontologies, like there's a whole bunch of different attempts out there at that, none of which really work for every domain, which makes sense. So it's sort of like I think
Mm,
we're even
mm.
though it's even though it's like 25-year-old semantic web, but even older, the technologies that underpin it are even older, but we're still figuring it out.
Yeah, and it's because of the scale of information and knowledge I believe I just got from you, where it's just like there's too much knowledge, there's too much information inside of a large enterprise. That's actually why
Yep.
maybe a good sort of like to go into, because in my research, it's exactly like what you just said. Finance, fraud, big finance companies, they're using a lot of ontology graphs. You have pharma, and it seems like large engineering organizations also get a lot of out of it. And
Yep.
so, and these guys
And
are all have
manufacturing. Yeah.
manufacturing. Okay.
Yeah. Yep.
And is
Yeah.
it, I guess, as a sort of a non sequitur question, but like deterministic processes. So I did this great interview with a co-founder from Zurich, ETH Zurich, of a robotics company called 7sense. And 7sense basically was just bought by ABB, which is the large Swedish manufacturing thing. and we were talking about AI, and they were doing machine learning for vision models to help robots navigate the physical universe. And we were talking about LLMs. And he's like, we're never going to use LLMs in this process because it's not deterministic. Inside of industrial manufacturing, all these different things, you need to completely bound this robot with a deterministic thing. So you can know, well, 100% of the time, this thing is not going to fail under these conditions because lives are at stake and all these different things. Whereas the LLMs are like probabilistic, like you never get to 100%. There's no way that you're going to get a probabilistic system to give you the same thing every time, which is the beauty of it, but also like why you would not use that in a manufacturing floor. Is our knowledge graphs and ontologies part of the deterministic computing, or is it something
100%.
else?
Yeah. It tracks almost exactly to that earlier distinction I made between the symbolic AI and the neural network side.
Yeah.
The fundamental attribute of a symbolic AI system is that it's deterministic or permits deterministic, stuff over it. And with AI, it's all stochastic and probabilistic. That famous early paper that Emily Bender and Timnit Gebru did about calling LLMs stochastic parrots,
Mm-hmm.
that's nothing has changed about that. Wally, God, I wish he was still on. There was this guy, Walid Saba, who talked really eloquently about that. Unfortunately, he's not with us anymore, but he would have been a great person to talk to about that. But yeah, no, it's almost a perfect one-to-one, deterministic on the symbolic AI side and probabilistic on the LLM side.
So it is. Interesting. So that is neurosymbolic AI. Okay.
Yeah.
Let's go into the history. What are your favorite details or facts about the history of
Oh,
neurosymbolic AI? Because it comes in the 50s, right?
it's
Yeah.
first I'll say I'm new to it, but the guy
Yeah.
I was interviewing last night lived the whole thing. I mean,
Oh, interesting.
it's literally I don't think he wasn't old enough to have been at Dartmouth in
So
1956,
it came out of
but
Dartmouth.
he so 1956 at Dartmouth this is like, a little bit, you lived in San Francisco, about the startup world.
Yep.
Like I remember 10 or 15 years ago, I was in Seattle and probably similar parallel
Yep.
universe kind of thing. And all the buzz like in the startup world, there was this truism
Mm.
that if you wanted to raise money, you called your solution AI.
Yep.
If you wanted to hire engineers, you called it machine learning.
Yeah.
You're doing it's just, again, back to the domain view perspective on a thing.
Yeah, interesting.
And so the term AI, it turns out that the term AI was coined, and I forget the exact story, but the guy who coined the term was at a conference in 56 and he needed to raise money. And he goes,
Minsky. Is it Minsky?
artificial intelligence.
Is it
Yeah,
Marvin
it
Minsky?
wasn't Minsky.
Okay.
It was McCarthy, I think was the guy's
Okay.
name.
Yeah.
It's again, I didn't live this and I haven't studied it like these other guys have, but I've got the tendrils back, pretty clear in my head, like where, like the mid 40s is when the neural network stuff started with
Oh,
the
interesting.
initial attempts it goes way back. It's crazy and the same thing, but really AI is best known, the history is best known as like the 80s stuff around expert systems and decision support.
Yeah.
That's where like and Eliza, the first chatbot, came out of that era and stuff. So so there's all kinds of interesting details in that history. My favorite one has to be the fact that the term AI has been a marketing term from the instant it was created. So yeah.
So we could talk about how AI is always AI. Like as soon as we get something like natural language processing, now that it's completely dominated by LLMs, it's no longer AI. It's just like what we have. So
Yeah.
AI is always a
Well,
future. Yeah.
that's something that drives me nuts is
Mm-hmm.
that that Sam Altman and his
Yeah.
pals have appropriated the term AI for their own. That's what Chat GPT
Yeah.
is. That's what. Well, yes, that's true. But symbolic AI and NLP and generative adversarial networks and robotics and computer vision. Those are all AI as well. You
Yeah.
can't claim the
Interesting.
whole field. Yeah,
There
it's
was a
like I
marketing
think
switch.
what's her name? Yeah. Karen Howe said in her book, it's like you invent the bicycle and you claim that you've solved transportation. It's like, nah, I'm pretty sure
Yeah.
that's not the case. So,
Yeah.
yeah,
And
yeah,
this is the crazy thing with it's why I had to leave. Is just there's a hollowness to it. I still think it's a great place to do business if people are interested in AI or ML because you can go find those ML engineers. You can, like you're just discussing, is like they're all there because it's like that's where you get jobs for it, and so it's really interesting because you meet really interesting and knowledgeable people. But there was something special there from 1960, 1960 to 2020. I would say 2020 is when it finally stopped, where it
Yeah.
became
Yeah. I
sort of
was.
hollow.
Mhm.
Go for it. Yeah.
Yeah, no, I was there in the mid '90s, and
Mm-hmm.
it was such a great. Oh, and these are some more of my favorite details about the origins of this stuff. At San Francisco State in
Mm,
'95, I think era, they
interesting.
did a series where they had. It was kind of like because this is '95. I mean, Netscape
Yeah.
is through 2 years old at
Yeah.
the time. It's like the very dawn of all this stuff, and but they bring in like Vince Cerf, and like originally the internet found, like the true Al Gore or whatever, the internet.
Mm-hmm.
But among the other two speakers were Ted Nelson. Do you know him? Do you know about him?
Yeah.
Fascinating
Yeah.
guy. He's the guy who coined the term hypertext
Okay.
in a book called Computer Lib Dream Machines way back in the 70s. Kind
Okay.
of like, yeah, really interesting guy. And he had this whole project called Xanadu, which you may have heard of. It's
Well, I've
a
heard.
it's a
Yeah.
legend in Silicon Valley. Yeah. It's spelled Xanadu, but it was like largely regarded as the biggest vaporware
Oh,
product in history. It just like he worked on it. Autodesk funded him for many years. He had funding from a lot of places. He was a really kind of a charismatic and colorful guy. Everybody has stories about him. But so I met him, and I was like, wow. So I really got into like his
in the 90s.
conception of hypermedia. But then after that, I think the next talk after that was Doug Engelbart. Do you know his
Yeah. Yeah.
name?
Yeah. Yeah. Yeah.
Because
Yeah.
yeah, you might have met his daughter Christina. She still runs the Bootstrap Institute. I don't know if she still does.
Bootstrap Institute. That's
Um,
very cool.
yeah, Bootstrap was his bootstrap.org, I think was his place. But Doug Engelbart was a guy who in 1945, he was flying home from World War II from duty in the South Pacific Theater at the end of World War II. He's in a waiting room waiting for a plane, and he picks up the Atlantic Monthly and reads this article called As We May Think. Have you ever heard of this? If you haven't
Vannevar
read
Bush.
it,
Vannevar Bush.
yeah, Vannevar Bush. Yeah. Yeah. So he picks up Vannevar Bush's As We May Think article, and then he gets back to San Jose. He's living in the middle of like an orchard, which is what Silicon Valley was back then. And he envisions the whole future that we're living in. I don't know if he got to this whole dystopic and shitified part of it, but he envisioned a lot of it. I think it was Howard Rheingold wrote a really good piece about him. You could probably Google it about that vision he had. It was just amazing.
Mm,
So anyhow, the again back to the heritage of it, like and this is, I think, germane to what you were talking about earlier about the human focus of this,
mm,
is that Engelbart saw all of this as a way to augment human intelligence, not replace it. He was always, I think, his
mm,
augmented, one of his system ideas had the name augmented it. He's also the guy who did the mother of all demos. I
mm.
hope you've seen that.
Yes, yeah. The one in the 1970s,
Yeah.
whatever. Yeah.
Yeah, because he wants to do all this cool stuff, so he has to invent like files and folders and graphical user interfaces and the mouse and like, yeah, it's just insane. Yeah.
Okay, so there was a question I had about that's really interesting about Engelbart. Do you know if he invented the file system? Do you have any like because
I don't know. That's a really good question because I know a lot of and I'm not a deep
who
computer
invented the
science
file
nerd.
system? Yeah.
Yeah, I don't, but I don't know that it's often criticized as like a flaw of modern computing,
Well, and
is
Bill
that
Gates
kind of skeuomorphic adoption of files and folders. Yeah.
Bill Gates tried to. He thought that you could basically in the 1980s and the 1990s create a relational database and a file system at the same time. This is actually probably going to lead us back into ontologies. So like it was this big dream to basically combine a relational database with a file system, and it was his white whale, and it didn't destroy him, but it very much veered him away from the reality because apparently you can't do it. And this gets back to an excellent question that was going around in the LinkedIn knowledge management stuff. Why? And I would love to hear your perception on it, because we have relational databases. For the listeners who might not know, it basically allows you to relate. Who am I to go down this path? But basically, there's, it's like relating two sheets together, or relating two Excel sheets together, where you have rows and columns, and those databases can be related to each other. I think that's what it is, basically. And so, why did that win over in the tech world, rather than these knowledge management ontology type of things? Why is a relational database the way that we do it with a schema and all these different things, rather than these other solutions that might work better? Do they work better? What do you think about this?
Well, it depends on what you're trying to do. Like for a
Okay.
lot of things like transactional stuff and things like that, relational databases are definitely better. And I'm like, you should, Juan Cicada, if you want to
Okay.
go to town on this, get him on your show.
Okay.
He could go, because he's a old school database guy and a semantic web head, goes way back. He is like, he could rock your world with all this. But the main insight I take out of that distinction is, well, one, 98% of the data in the world is trapped somewhere in a relational database. And I've done, like 30 years ago when I just first started doing this stuff, I learned SQL because you had to build, like I've always mostly been a content person, and you had to build your own CMS. And I was
Yeah.
like, well, I guess I got to learn database stuff. So I know how difficult it is to write joins and all that stuff to, but the way you just described it is exactly right. It's just like a stack of Excel spreadsheets that are connected with keys and schemas, so you can kind of navigate from one thing, connect orders and customers and stuff. But that notion of like, well, and one thing I didn't talk about when I talked about RDF is its structure is the simplest. It's like a simple linguistic structure: subject, predicate, object. Larry knows Stewart. And so you could have a table that has people, and Larry across a row and Stewart, and where they intersect is the notion that they know each other.
Mm.
So representing data in a table, it's, again, I'm not enough of a database expert to say why, but there's good reasons to do it, and it's handy, and it probably matched some mental model that was in most software engineers' heads at the time, so it probably made sense.
Mm.
But the benefits of putting data and metadata, more importantly, in that subject predicate object format in what's the RDF, that's the resource description framework, which is sort of like analogous to HTML, like whereas HTML is the standard that permits you to create documents that you can share. RDF is the format that, and they're both W3C standards. I can see your screen. It's kind of small.
Yeah, I can explain
Yeah.
what's going on, because as you're talking,
Okay.
I'm starting to connect it together. So I wanted to look, because I can see a relational database and I can see that in sheets, right? So I can go to a sheet and I can see a specific sheet, but I wanted to understand, what does RDF look like in visualizations as they come up, basically. This is probably a good one.
Yeah, just
Yeah.
two dots and a line between them, like any of those
Okay,
form,
interesting.
like that. Yeah. And what's cool about it is that you're just connecting ideas, each of which, and this
Interesting.
is a really important thing, and this is why this is, I think, a reason that I don't know how this might manifest in the current, generative AI dominated world, but each of those, the subject, predicate, and object, they each have a unique URI, a uniform,
Oh.
like a URL, but they each have a unique identifier. So you can, which permits, it's like, you have meaning. That's how you start to get the meaning. And there's also one of the things, like the reason that schema.org, annotated web annotations are so popular is this notion of linked data.
Yeah.
That's the one of the concepts that comes out of the possibilities that RDF creates, is this notion of the ability to link data, which is not trivially easy, but it's a whole lot easier when you have a graph structure than when you're trying to navigate a tabular
Mm.
structure after the fact. Um, yeah, yeah, it's
Hmm.
it's fun. And this is why I think that this is probably, when you talked about like this, the popularity and support and appreciation of this, I think a lot of it, I'm just thinking this is the first time this thought's occurred to me, but I think a lot of it comes out of the fact that, like, well, first of all, modern developers are more into, like, representing data in JSON docs or NoSQL databases or something like that. And to the extent they've thought about logic and reasoning, it's always, algorithmic codes that they've worked with. Backing out of that and coming back in, you're looking at your
Yes.
data from this fresh perspective of RDF, because on top of RDF is all these, there's like a schema language, there's a query language, there's a ontological language, there's a constraints language, all the stuff you need to, like, do right by your data and turn it into knowledge. That's the point of the whole thing, is turning your data, or or ex-
Mm.
you know inferring knowledge or articulating knowledge as RDF. That's where the knowledge and data connection comes in.
Okay, that's really interesting. That made it much more clear about this question I have, which is why engineers, going back to what we were talking about earlier, they just don't like doing it. I think they're habituated to thinking logically in a relational database environment. I guess that gets to the, maybe another 10, 15 minutes, is ontologies, why it just takes so long to understand. It's probably been 2 years, or yeah, it's been about 2 years since I first started hearing about this stuff from Jessica, and it's taken me 2 years to have this conversation of like being able to track all of these different things, and I'm now sold on the fact that they are really important, and the company that I'll eventually build will sort of be built off of this core idea of having an architectural understanding of the company as itself. I guess that goes back to the relational database thing, because that's what the engineers are thinking of that about that in their own world of having these relational databases and doing the data for their part of the company. But there are the founders of the company. It's such a big problem. I noticed at the company that I was the knowledge management, they wanted this data, but they couldn't get it because it was all just structured so poorly. So it would have taken both a knowledge management person and a knowledge architecture and like $10 million in order to get this thing in this ontology. But is that the hard part of getting the ontology, is that you just have to pay like 10 knowledge architects to go through and think architecturally about each of these different pieces and how to connect them in these RDF statements?
Yeah, I haven't done, it's like, it's interesting. I haven't done it at that level in the way I've been in situations like the one you just described, but I haven't had to do ontological work there. Typically, I've always done, there's sort of and this might be another disconnect between engineers, is that like a lot of the work you do in ontology and domain modeling looks a lot like, you end up with something that looks like an ERD, like an entity relationship diagram. And that's sort of how an ontology starts. But there's so much more to it, in the sense that like one of the ways I've seen it described, it's like kind of the way you just were thinking about it shows me that you've got it clear in your head that like you really feel the benefits that an ontological understanding of your organization, how that could manifest in systems in that organization. The flip side of that is that every organization in the world has not done this to this point. And one of the things that knowledge graph technology can do is build like something like what's often called a semantic layer, sort of an ontological understanding of your organization, independent of all those crazy systems, all the CRMs and content management systems and databases and, and sales. Yeah. Independent of all that, you can develop the understanding of your organization, articulate it as an ontology, and then map to the stuff in there. If you haven't, God, here's another person who would be great to talk to, is Alex Bertice at Netflix. He built their their ontology and ontology language. Whoa. And did a brilliant job of that. So sort of showing that like, well, we got iceberg stuff over here, we got Java stuff over here, we got to, stitch it all together, and used and he said, I think I'm not sure if I'm quoting him exactly right, but basically he said, yeah, I sold him RDF. That's how we fixed it. So it's both. Ideally, I would love to see every startup founder get versed in RDF technologies from the start. It might not be the right way for everybody to do it too. That's the truth is there's other ways you can do, like there's other ways you can do logic besides OWL, like Prolog and other computing languages. There's other ways you can structure data that might make sense for some organizations, but for a huge number of organizations, and for any organization that wants to understand its kind of enterprise, in what a friend of mine at Metafax calls the enterprise information architecture. Like, what are all the systems you have? What's in those systems? Kind of like the Netflix stuff. That you can really, the best technology to do that kind of thing right now is RDF and this stack of semantic technologies.
Okay, interesting. Oh man, that's a good insight. What are all the systems, and what do you have in those systems is a really good question. Have in these systems.
Yeah, I think that's how you start. I've been a miserable failure at all this communicating with executives for about 30 years now, but I get slightly better every day. And I think that's the thing that it's going to take, is like, hey, you want to answer questions about your business? Let me help you out.
Yeah, that's
yeah.
Interesting. Oh man, I had so many questions that came up, but I'm having difficulty getting back to there's a sort of, it's like all these other types of data. There's like RDF might not be logic. What did you mean by logic? You said something about there's a logic to it, and you don't need RDF for that specific logic.
Well, that's one of the things. Like before, like another here's another one.
Mm.
He's Jan Zossman, the guy who founded Allegrograph, one of the early
Mhm.
graph databases, where you store this stuff. He built, I think, his early systems he built with Prolog, and I'm not a
Yeah.
programmer. But I
Interesting.
know that there are other languages that were concerned with like reasoning and the ability to reason over stuff.
Yeah.
Um, and they're different from like just algorithmic, I don't know enough about programming to
Yeah.
describe the difference. But and there's still people today. I was just talking to a friend at I can't really say, but another big semantic technology company that they don't use owl. Owl is it's a resource description framework based. It's called the web ontology language.
Mm.
How it got owl, it's like anyhow, it's like one of those tech
Yeah.
acronyms that you have to figure out. But anyhow, OWL is based on description logic and set theory. And so there's this kind of like, and I don't know enough about
Yeah.
logic and the application of logic in a business sense to understand the
Yeah.
limitations of that. But apparently Prolog and other similar languages permit bringing other kinds of logic to bear. So that's where, and I've often been like a consultant or a contractor, in situations where, um, I'm just solving problems for businesses. In many cases, I don't care exactly how you do it, like
Mm.
whatever, because your tech team is going to have like their opinions. Your IT people have opinions about what kind of infrastructure they want to build. The executive, like balancing all that is always a challenge. But I got to say that like for a huge number of the problems I see nowadays, RDF based semantic technology is like a really good idea.
Yeah, I think I'm ready to start doing the RDF. I've got my Anki thing that I showed you before we started recording, and that has me putting all of my language for all the things that I do inside of this system, and I've now figured out how to get an LLM inside of that as well, so it can help me with this first step, which is controlled vocabulary, and really establishing where what are the terms that I really want to use, and then the taxonomy and the thesaurus of building like hierarchical relationships between it. I think I now understand those things conceptually.
Yeah, you're
Now, yeah.
totally in. You've dipped into Jessica's ontology pipeline. I love
Yeah.
it.
um it's wild because it was like we had her speak at our AI Whisperers event here in Buenos Aires a year ago, and she was talking about all these things that would totally flew over my head. But now I think I understand it, and it really does feel like that's the last question I guess we can talk about is like, what's your vision of the future in terms of how AI interacts with it? How has AI helped you do things that you previously weren't able to do, or has it given you ideas? And like, what is a vectorization like, and all that stuff? Is the ontology complementary to vectorization?
Yeah, absolutely. It kind of goes back to that. I think the bigger distinction is the one you made earlier between deterministic and stochastic systems, that like you need both. I mean, the stochastic and probabilistic systems are so good at so many things that
Mm.
those have to be in your architectures. But I think we're at a point, where we're 3+ years post Chat GPT launch, we're starting to see the limitations,
Yeah.
like, and I don't know who to believe anymore either. And
Yeah, me neither.
this might be an AI problem, like,
Yeah.
is enterprise adoption slowing or
Yeah.
growing? What's going
Yeah.
on?
Yeah.
It's
Yeah.
so,
Yeah.
but regardless of that, it's clear to me that these are such logically and obviously complementary technologies, each really well developed, each with many people who have navigated in parallel both parts of them. So there's all the pieces are there to put this together. I'm not aware. I'm constantly on the lookout for my podcast of people who have actually done like neurosymbolic architectures
Mm.
that solve this. But it's also easy to infer from a lot of stuff you see from like Perplexity and Claude and other
Mm.
places that they're not just LLMs. They're able to cite sources, which an LLM can't do. It'll just make up a URL that
Mm.
looks like a
Mm.
URL. So
Mm.
there's obviously some
Yeah,
hybrid
out.
architectures already emerging. But anyhow, but the question about the future, I think Walid Saba talked about this in an interview I heard years ago, and Jim Hendler was just talking about it last night when I interviewed him, is that we'll have something like decoupled, modular architectures where you'll have things that are good. It's kind of like the microservices that have emerged over the last, 10 or 15 years or longer than that. the separation of concerns, like, hey, I'm really good at discovering stuff and generating lists of possible taxonomy terms. Great, do your job. Hey, I'm really good at articulating a human vetted version of that list in an ontology or a taxonomy that we can do cool stuff within our systems. That's clearly a more deterministic. So there's this separation of concerns.
Yeah,
I
interesting.
think I think the way that'll manifest is in these like decoupled architectures. So I think that just makes sense, and I think that's just sort of a well, duh. That's just how technology architectures work these days.
Yep.
But my hope is that the future, just constantly it gets more knowledge in there because it both brings the humanity. The whole thing about knowledge architectures is they capture human knowledge, and put it in the computer. And like to what you said a couple things earlier about like, Silicon Valley would just assume, well, let's just get rid of all the people and have agents do everything. And
Yeah.
then we can sit on the beach and you can just collect your UBI and do whatever. I don't know. They haven't thought it all the way through, I don't think.
Yeah.
But I really do think that's one other thing I'll say. And this is more about the past than the future, but I think it's going to continue to be true in the future. I've done probably 300 podcast interviews over the last 10 years. Literally every single one of them at some point talks about, well, this technology is great. And this cool management thing we've done, agile or, whatever it is, this is all great. But fundamentally, it comes down to human beings and how they behave and the culture changes, the behavior changes that you have to make to actually implement stuff. And I don't know that many machine learning engineers or GPT based enterprises have thought that through. I think they really are just focused on like getting rid of the people. And I'm like, well, first of all, that's who this should be for. And second, it's like that's where all the interesting problems are. And you can't
People's
always solve, you can never solve those.
Yeah.
Yeah. So anyhow, I'm ranting a little bit now. Sorry.
No, I love it. Thank you so much for coming on the show. Go find the Knowledge Graph Insights podcast to hear Larry Swanson's. Where is it on Spotify, on YouTube?
It's on Spotify, YouTube, all your favorite podcast platforms. Yes.
Cool.
And just kgi.fm is the short URL for it.
Oh, I love it. kgi.fm. We'll put that in the show notes. Thank you so much.
Thank you so